Class 10th, we are starting with our next topic from the chapter acid, bases and salts. We are doing acids and bases today. We have covered up indicators topic before this. So first I'm taking acids. What are acids? Acids are substances which dissociates means they will break in water. This is very important. They will break in water to give hydrogen ions. Hydrogen ions are H plus, or we can also say hydronium ions. Hydronium ions, that is H3O plus. Example of acids: hydrochloric acid, now those substances which will dissociate in water, like I'm taking hydrochloric acid. In water means I'm taking its aqueous solution. In water, this is dissociating, breaking to give which ions? H plus ions. So if in water this breaks to form H plus ions, that means this is an acid. So in aqueous medium, if we take aqueous medium, then the H plus ions which are formed here, they further combine with water molecules. And if they are again combining with water molecules, what they will form? They will form hydronium ions. So that is why we have written H plus ions or hydronium, because H plus will change to the hydronium ion in water. So this H plus formed here combines further with water and changes to hydronium. So that is why we can write the substances which dissociates to give H plus ions or H3O plus ions. These are known as acids. So if this reaction we want to write HCl1 with water, then what we'll write is HCl aqueous plus water. We can write like this also. And then here we'll write H3O plus. We will not write H plus like here we have written H plus, but here what we'll write is H3O plus ions. So both are correct. We can write the reaction this way also. We can write it this way also. If we are just writing acid in aqueous, we will write H plus. But if we write acid in aqueous medium plus water, then we are writing hydronium ions. This is the only difference. Otherwise, both the reactions, they are fine. Next topic after this, now after knowing what are acids, now one investigation here we have. What we have to investigate is, like I said, water is must here for the substance to dissociate to form H plus ions or the H3O plus ions. Preparation of, we are preparing HCl gas. And then we have to check action of litmus on this HCl gas in anhydrous and aqueous medium. Anhydrous and in aqueous medium. Prepare HCl gas first of all, and then check the action of this HCl gas on in anhydrous and in aqueous medium. For this we are taking a test tube. In this test tube we are taking NaCl. It's a white color salt. We are taking NaCl here. 1 gram, approximately 1 gram of NaCl we are taking here. So what we have here is NaCl, sodium chloride. And then to this we are adding approximately 5 ml of concentrated sulfuric acid. What we are adding here is concentrated sulfuric acid, that is H2SO4. The two, they will start reacting. So here we have to close this with a cork. What we have to put here? A cork we have to put to close the test tube. But through this we are passing a delivery tube. So now when the two substances, they will react with each other, our observation here is NaCl reacts with concentrated sulfuric acid, and when the two, they will react with each other, what they are forming? Sodium sulfate and HCl, hydrochloric acid, will form here. But this acid form here is in a gaseous form, and plus what we are getting is sodium sulfate solution. This is also liquid, but this we have taken is solid. Now to balance this, we need 2 NaCl2. So here which gas is forming here is HCl gas. This gas forming is coming out here, and through the delivery tube it is coming out. So what we'll do now here is we will keep here a blue litmus paper. This gas will touch the blue litmus paper and we will not find any change in the color of the blue litmus paper. But if this blue litmus paper, color will not change. But now we will just moist this paper. We are taking a moist litmus paper, just wet it with the water. We put water on this. And now when this gas, hydrogen gas, will touch this blue litmus paper, it will start changing to which color? To the red color. It will start changing to the red color. Now we know blue litmus changes to red color only when it comes in contact with an acid. Then only its color will change. So here hydrochloric gas is there, HCl gas is there. Why the color of the blue litmus will not change when we will take it in a dry form? Because for acid to show its acidic behavior, water is required. Only in presence of water, what will happen to this HCl? HCl in water only will dissociate to give which ions? H plus ions. So H plus ions given by a substance, then only that substance is acidic in nature. So this is acidic in nature, but it can give its H plus ions only in aqueous medium. That is why when we take a dry blue litmus paper, no changes here, because this HCl gas coming here is not dissociating to give the H plus ions. But when we'll take a moist blue litmus paper, water is there. So HCl gas in presence of water will dissociate to H plus ions. These H plus ions, when they come in contact with this blue litmus paper, that blue litmus changes to red in color. So this is our one investigation, that for a substance to show its acidic behavior, water is must, aqueous medium is required. Now next topic is classification of acids. How to classify acids? There are different ways to classify acids. Several ways are there to classify acids. The first one we are taking is on the basis of source, from where we are getting it. What is the source of this acid? Based on source, acids are of two types. First one is called organic acid, and second type is inorganic acid. Now from the name it's clear, organic means living. So those acids which we get from the natural living sources. Natural living sources are plants and animals. So those acids that we get from plants and animals are organic acids. Examples of these are acetic acid, oxalic acid, formic acid. These are organic acids. So now I'm taking these acids and their natural source. Acid. First example we have taken is acetic acid. I'm taking more examples here. Citric acid. The next one we have is a tartaric acid. Oxalic acid. And one more example, lactic acid. Lactic acid. So we're taking these acids. Natural source of these, from where we get these acids. Natural source. Acetic acid is vinegar. It is a vinegar. Its natural source is a vinegar. Citric acid is obtained from the citrus fruits like from oranges, lemon. Tartaric acid is obtained from tamarind. And oxalic acid we get from the tomatoes. Lactic acid we get from curd. So these are the natural sources of these acids. Since we are getting them from the natural living sources, all these are called organic acids. After organic acids, now moving on to inorganic acids. The acids which are obtained from minerals of the earth, from non-living things, these are called inorganic acids. Since we get them from the minerals, these are also known as mineral acids. Example, hydrochloric acid, sulfuric acid, nitric acid, etc. And these acids are corrosive in nature, so they should be handled with care. All these acids are mineral acids. These are corrosive in nature. That is why they should be handled with care. This is the first classification of acids based on their source. Now moving on to the second classification, on the basis of their ability to dissociate in aqueous medium. Since acids they dissociate in aqueous medium and they give H plus ions, but on the basis of their ability to dissociate in aqueous solution, these further are of two types: strong acids and weak acids. Now again, from the name itself it is clear, strong acids are acids which dissociate completely. They completely dissociate in aqueous solution to give out H plus ions. And examples of strong acids are mostly all these inorganic acids. These are the strong acids: hydrochloric acid, sulfuric acid, nitric acid. All these are examples of strong acids. Except for one mineral acid, that is carbonic acid, all other mineral acids are strong acids. And weak acids now are the ones which are not dissociating completely. They dissociate partially to give out the H plus ions. And examples are all these organic acids, these are the weak acids. So all organic acids are weak acids. So this is on the basis of their dissociation, whether they are dissociating completely or partially. These acids are divided into the strong and into the weak category. Now, third classification of acids. On the basis of their concentration in water. These are divided into two types. On the basis of their concentration means how much amount of these acids is there in a water. Based on that, these are of two types: concentrated acids and dilute acids. What are concentrated acids? Those acids which have maximum amount of acid dissolved in very less amount of water. Water is less while acid is more. Then these are called concentrated acids. While dilute will be opposite to these. Here amount of acid is less while that of the water will be more. So this is the third classification of acids. So there are three types or three ways are there to classify acids. The first one is on the basis of their source. Second is their ability to dissociate in aqueous solution. And third is on the basis of their concentration in water. After this, now there's one question. Why should dilution of a concentrated acid be done with utmost care when we are diluting a concentrated acid by adding water into it? It has to be done with utmost care. The reason is because this process of adding water to concentrated acid is highly exothermic. Lot of heat comes out during this. That is why it has to be done with utmost care. Now next is activity. Just to prove this thing that this is actually exothermic in nature, that is exothermic nature of dilution of an acid. It's a very simple activity. We'll just take 10 ml of water in a beaker. In beaker, we are taking some amount of water. There's water in this. Let's say 10 ml. And then slowly drop wise, what we are adding here is concentrated sulfuric acid into it. And when we are adding it drop wise, we have to stir it also. We have to stir the solution. And now you have to touch the base of this beaker. Just touch this base part of the beaker. You observe the change in temperature and you find this beaker is very, very hot. So what we infer from this, that when we add concentrated sulfuric acid to water to dilute it, lot of heat comes out during this process. That is why the bottom of this beaker is very, very hot. Now since this process is exothermic, so following precautions, they need to be taken while preparing a dilute acid must be taken, following precaution must be taken while diluting a concentrated acid. And this question is very, very important. What care has to be taken? Normally, when we are diluting something, we add water to that. But in this case, it is the other way. First, what we have to do is to get a dilute acid, like in the previous activity we did. First, we need to take water. And then to this slowly and slowly we are adding acid. Which acid is this? Concentrated acid. And side by side what we have to do is we have to stir this solution also with a glass rod. Slowly and slowly we add this acid and we are stirring the solution also. Like this, what will happen, since this process is highly exothermic, lot of heat is evolved. So when we are doing this process slowly, then that heat evolved is absorbed by this large amount of water. If water is added to a concentrated acid, the other way if we'll do it, then the heat generated may cause the mixture to splash and it can cause the burns. And even this glass container that we are taking for this process, that also can break due to that excessive heat. So that is why whenever we are diluting an acid, what we need to do is first take water and then slowly and slowly add concentrated acid to this. What do all acids have common in them? What do all acids have in common? We have done this thing. What is common in all acids? That they have a tendency to produce H plus ions in aqueous medium. This is common. H plus ion is common in all acids. They dissociate in aqueous medium, and what they are liberating, they are giving out H plus ions. Third example I'm taking is of acetic acid. This is weak acid. Normally for weak acid we use this arrow that shows dissociation is not complete. So see, all these, they have one thing common in them, that is H plus ions are common in them. Now next after this is bases. After acids we are moving on to bases. What are bases? The substances, they also dissociate. Substances which dissociate, and they also dissociate in water. But what they give? They give hydroxide ions. Acids they give H plus or hydronium ion, but they give hydroxide ions. So those substances which in water dissociate to give hydroxide ions are called bases. Example of base is sodium hydroxide NaOH. So in water, NaOH aqueous dissociate to give Na plus ions, and along with this it is giving OH minus ions, hydroxide ions. So this is actually a base. Now one very important thing is that all bases are not soluble in water. All bases are not soluble in water, but some bases are soluble in water. So a base which is soluble, a very important line, a base which is soluble in water is actually known as alkali. So there is a difference in a base and an alkali. So if difference is asked to us, then what we'll say? Those bases which are soluble in water, these are known as alkali, and the ones which are not soluble are called bases. Now example of water soluble base, that is of an alkali, is KOH, NaOH. And the example of water insoluble base is ferric hydroxide. After this we have classification of bases. Bases are classified, just one category we have here is a strong base and weak base. Like acids, the definition is the same only. Strong bases which are dissociating completely to give out the hydroxyl ions in aqueous medium are called strong bases, like NaOH. In water, it dissociates completely to give which ions? Hydroxyl ions, is a strong base. While in case of weak base, I am taking the example of, like we have done before, acetic acid dissociates to give which ions? H plus ions and acetate ions. But for weak, what I told you, we use this arrow that shows that dissociation is not complete. So strong bases are ones which are dissociating completely to give hydroxyl ions in aqueous medium, while weak bases, they dissociate partially to give less concentration of, I have taken the example of acid here, sorry, this has to be a base. Example is magnesium hydroxide or calcium hydroxide. I am writing this reaction again. See here, magnesium hydroxide is a weak base. So for weak bases, we are using this arrow that shows it is going this side and going this side also. That means it is not dissociating completely to give the hydroxyl ions. One more example of weak base is calcium hydroxide. This also is not dissociating completely to give the hydroxyl ions. So this symbol only tells us that actually this is a weak base. Now next question here we have is, what do all bases have in common? Like all acids, they have H plus ions in common. All bases, what they have common in them? That all these, they produce hydroxyl ions in aqueous medium. So this is common in all bases. Like NaOH in aqueous medium dissociates to give hydroxyl ions. Similarly, if I take potassium hydroxide, KOH, it dissociates to give K plus and hydroxyl ions. So this is about the bases, that what are bases, the classification of bases, and what do all bases have in common.